All right, hey everybody. I hope you're staying at home, washing your hands. It's just a crazy time, okay? I did want to go over the stoichiometry graphic that your book shows you on page 166, which is this. Hopefully that's in focus. Maybe. Just, all right. If not, I'll take a picture and put it up there. All right. I want to talk about this thing. Okay. So this is one way to look at stoich. Okay. And it's not my personal favorite way, but it is in your book. And if you're using that as your resource, I at least want to explain what it is. So it's basically this branched out thing where you have moles in the middle, okay? So you're saying you're having a conversion from mole of substance A to moles of substance B in any kind of hypothetical equation. You can see why I don't like it already, all right? But here we go. And then they branch these guys out to have other boxes, to have particles, or grams, some mass down here. All right. And this will all be of part A. This would be of substance B. Okay, so for example, okay, if you had a problem, all right, 15.5 grams of hydrogen react and produce grams of water, okay, in this type of equation, right? Hydrogen and oxygen react to make water. Balance your equation. So two of these, one of those, okay? Instead of using what I like, which is my kind of 5-step, do I have that somewhere? Right? This is how I like to think of stoich. All right? I like to think of it in a 5-step process for me. But if this doesn't work for you and you would rather do it this way, okay, you can. You do have to make sure that you balance your equation, okay? So you have a balanced equation. And now you just kind of follow the little chart, okay? So you start with your given. You have 15.5 grams of H2. You want to figure out grams of H2O. So you started with grams of particle A, of substance A. So in this scenario, I'm starting with H2, right? This is going to be my H2. So I need to go from here to moles of substance A, which is H2. So get out of grams, get into moles. And to do this is molar mass, so 2.02 to 1 mole, okay? Then I can go from moles of substance A to moles of substance B. Okay, so you use your mole ratio here, which in this case I want water. So I'm getting out of moles of H2, getting into moles of H2O. Okay, so this will be H2O up here. And I use my balanced coefficients. Okay, so that's nice. In this case, moles of H2 is 2. Moles of H2O is 2. All right, so that happens to work out. Use your coefficients. All right, and then it asks me to get to grams of water. All right, so you go from moles of my substance B to grams of my substance B, and in this case it's water. So get out of moles of water, get into grams of water. Mole to gram is going to be your molar mass, 18.02. Okay, you go beep, boop, beep into your calculator, and you make sure that all of your units cancel appropriately, and they do. And you should get, holy cow, an answer of 138.3 grams of water. Okay, it's still stoichiometry. Okay, it's just looking at it with a graphic, okay, and going from box to box instead of looking at it in 5 steps. You know, balance your equations, start with your given, convert to moles, mole ratio, convert to whatever unit they want. You use what makes sense to you. I just at least want you to be exposed to all of the possible resources you have out there, okay? Stoic can be tricky. Good luck.